Hello. So we are back, and this time we have a classic laptop to repair. I mean, we fixed so many Toshiba Dynabooks, and all are coming from the same company, which probably they are selling them. Also, they sent me a candy in the package. That's so nice from them. Now let's read the customer email. Customer, which is a computer business. Hi, Sorin. We have a Dynabook. This has our usual charging issue, which you have done few of now. Yeah, we did. Remember, it was like a shorted MOSFET issue. MOSFET replacement, nice, easy pizza, I hope. And I have so many people on the emails saying, sorry, this must be an easy pizza job. Now, I think the people actually misunderstood the thing with easy pizza. Okay, this it is coming on, but probably it's not charging. I think everyone misunderstood. I mean, when I'm saying it's an easy pizza job, that doesn't mean that's a cheap job. It means it's an easy pizza for me. The laptop it is coming on. Let me shut down the laptop. Okay, the laptop is off. Let's find a charger. Now 19 volts. Plug in the charger. You seen that? I mean, the current goes insanely high, like 4.8 amps. You can see, and obviously, if you leave it like that, 4.8 amps, the battery is getting disconnected. Yeah, so we still have like insane amount of current on the main power rail. The battery is getting disconnected, and the laptop it will work on the charger. Pressing the power button, it's taking. You see, it's taking 800 milliamps, and the laptop is working. It's working fine. So the issue here, it is a shorted MOSFET. I'm pretty sure about that. Otherwise, why the laptop it will take insane amount of current. And the laptop is open. Yeah, that's a classic motherboard. And the shorted MOSFET, I can bet, nearly I can bet, is that one. Yeah, that one, that MOSFET. This is a classic fault with the Toshiba Dynabook. Now, if we are going to the MOSFET, let's go under the microscope and check together. I can't see the MOSFET, it's too small. So that's the MOSFET, which I believe is shorted. And if we are checking the MOSFET, I can't. This probe is too big because it got broken, but I can check from here to here. Check that, check on the screen. Yeah? Like what? Like 1 ohm, you can see. So this MOSFET is gone. Like I said before, this is a classic fault. Now replacing the MOSFET, and here is another story. But before, yeah, we are going to replace in the MOSFET. I will come back again with the importance of a power supply. If you use like a normal charger, you will see nothing. I mean nothing. But with the power supply, you can see actually the current is going high, then it's going low. So we can figure it out the fault before opening the laptop. I seen comments on the chat and people ask, yes, sorry about the adapters. You know my channel for so many years. I mean, I work on that computer shop for like 10 years. We didn't have something like that. I mean, I always like got like faulty charger. You get a faulty charger, you cut the cable, and you have two wires, plus and minus. And you have a bunch of cables from different laptop brands, and you just connect all plus together, all minus together, and you have a plus and minus and a bunch of cables. And that's how you connect that cable to the power supply. In a case, of course, you don't want to buy the adapters. And you'll ask, okay, sorry, but what about the middle pin thingy? Yeah, the middle pin. You pick up like a big charger, like probably, maybe you don't use a charger. You use the power supply. You can find on Google actually the resistor which has to be placed between the charger ID pin and ground and plus, or only with the ground. Now replacing the MOSFET, it's, I mean, how we can figure it out? Channel P, channel N, Now I know this is a channel N, but it is matter what channel it is? No. No, in this case. Yeah? Not on this case. When you're dealing with input MOSFETs. Yeah, because people ask, sorry, how can I figure it out? It's not when it's on the input circuit. Yeah. And maybe for the people they know repairs, they will say, sorry, you are crazy. You are getting older. Actually, I'm not. So, okay, on the power supplies, yeah, there is no question about you check on. I'm not checking on Google. They are channel N, yeah, so you are replacing that most of the channel N. But on the input circuit, and this is on the input circuit. Wait, my tweezer. One second, let me fix my tweezer. Yeah, all good. Yeah, the battery it is disconnected. We have like 480 degrees on the hot air, about 50% air, and the MOSFET is out. Now, what do you think it will happen if you use the channel P here? Hmm? I mean, I can try to find a channel P and replace it. But what will happen? Because happened to me. Like sometimes on the input circuit, you use a channel P instead of channel N, or channel N instead of channel P. What you will see, and that the MOSFET it will work. I mean, it will pass the voltage. Probably it will not charge if it's a different MOSFET. But what you will see voltage dropped between the source and drain, yeah, and that's what you have to pay attention. You plug the charger, okay, what is the voltage before the MOSFET? What is the voltage after the MOSFET? The lowest MOSFET resistance, which is way under 0 ohms, it's only when you have the right MOSFET there and it's right biased, yeah, you have the right voltage on the gate compared with the source. And now you'll ask, sorry, but from where MOSFETs? MOSFETs you can get from anywhere, like any motherboard. Their channel usually they are channel and on the power supplies, like this one. So we'll be getting this MOSFET. You see, the both MOSFETs are the same, yeah. So channel and MOSFETs. It is important the current, the voltage, all those kind of stuff, like the gate. No, it's not. I mean, any of these MOSFETs can handle probably more than 10 amps, or anyway, around 10 amps. Yeah. If it's a gaming laptop, yeah, probably you should pay attention on the MOSFET. But this, this is like like a light laptop. We have a CPU there. I mean, how much current can this laptop take from the charger? Probably not more than 3 amps. Yeah. So any MOSFET can handle like 3 amps. How we can, yeah, like that. You can see you have the metal plate there, so that's how I know the position of the MOSFET. Good. Let's solder the MOSFET. And now the next logical question is, okay, sorry, you're replacing the MOSFET, but why the original MOSFET died? And actually, that one is a very good question. Perfect. So the MOSFET is soldered on place. Straight, yeah? Maybe I need my glasses. We need to cool down the motherboard. If you ask me, I can't even answer to that question. I mean, why that original MOSFET died? And I can only assume it's probably like a faulty batch of MOSFETs, like, dodgy MOSFETs from the manufacturer, because otherwise, a MOSFET with this sort of current cannot die. The MOSFET can die from different reasons, like, okay, too much current, which is not the case here. Then too much temperature. Yeah, the laptop can get hot, like 150 degrees, and probably it will get shorted. Why the laptop it will get hot? Drawing too much current. Yeah, but we already established here is not too much current. Less voltage on the gate, and we've seen that before. You remember? So if you don't have the right voltage on the gate, your MOSFET is like half open, and the way how the MOSFET works, like it's a variable resistor. The MOSFET start losing current and you start getting hot and can easily reach like 150 degrees. Let me plug the charger. And of course, you'll ask, okay, sorry, but we can check that. Yeah, of course, you can check that. Of course. So plug in the charger. Actually, let me plug the battery. Plug in the battery. Plug in the charger. The laptop is taking like 480 milliamps, 130, which is the pre-charge current. Probably the battery is actually it's not discharged because the laptop it was working on the battery. Yeah, it just needs a time. It just needs a little bit of time. Anyway, let's check together if our MOSFET is working fine. Let's see. So we have, well, I can't see here. Let me go under the microscope. 1 second. And we have our MOSFET there. Check there on the current 880 milliamps. So that's the charging current, and it's right, yeah? Kind of low the charging current, but that's how this laptop works. So you have the MOSFET, you have the source, you have the drain here. So you can check if the input voltage is the same with the output. So we have 18.9 here, and we have 18.9 on the output. Yeah, so basically no voltage dropped. And on the gate, check that on the gate. I will raise the range of my multimeter. On the gate, we have, check that, 25 volts. You can see 24.99. That means between the source and gate, I have from here to here, check on the screen, 6.1 volts, which is about the right voltage. So it's like nothing wrong with the laptop. That MOSFET just died by itself. I can't even explain. No, I can't. No. Just probably a bad batch of MOSFETs from the factory. Okay, good. Let's plug the M2 drive. Another comments was, sorry, why you work and you plug and unplug the M2 drive if the laptop has power? The M2 drive doesn't have power if the laptop is off. If the laptop is on standby or sleep, yeah, then it will be power there. But otherwise, it's safe to unplug and plug back the M2 drive. Now we press the power button and nothing happened for some reason. Pressing the power button, yeah, the laptop it is coming on. We didn't reset the BIOS, that means the laptop is coming on straight away and everything is fine. Charging fine, working fine. Can you check that? Yeah, if it's charging, of course. Of course, we can check that. So we have ground and we have plus, and we have like 8.143. Oh, for 2, it is charging slowly. For 3, yeah, because the charging current is low. Why the charging current is low? I mean, the charging current has, up and down. So you use like a high charging current, then the battery is getting charged faster, but the life is lower. If you set up like a low charging current, then obviously the downside is the charging time, but the battery life is longer. So it looks like the manufacturer on this case choose like battery life instead of, like a fast charging. All good, charging fine, working fine, no issue. Okay, hopefully I made some light understanding the power input circuit on this laptop. You will ask now, okay, sorry, but that MOSFET is there like a single MOSFET. Actually, it's not single. You have one here, yeah. Then you have 2 here from the USB-C. Then you have 2 here behind. So you have 2 MOSFETs here, 2 MOSFETs from the USB-C. Then the power rails are meeting together. Then it's going through these 2 MOSFETs, and then we have the charging coil here, proper hot. Can you check if the charging current is actually a control current and not like a random? Yeah, you can. You have the current sensor after the charging coil. So this is the charging coil, you have the current sensor. If you show the current sensor, check there the current is going up. So you can tune up the laptop. Yeah, like it's your laptop and you want battery to charge faster, you solder a resistor over this one. You want to charge slower, So you have longer battery life. Then you replace the resistor with a higher value one, or you can add like in a serial mode two resistors. The resistor is like 0.00 something ohms, very low. All clear? Yeah, I'm happy I helped the customer. They've been right when they said, it's a MOSFET. So I'm gonna stop now. I will say, thank you for watching. Like, subscribe if you like the video, and see you on the next one. Bye.